Out of 50 responses, many could tell me what HIV stood for and what it does to the body. HIV stands for Human Immunodeficiency Virus and works by targeting the body's immune system. HIV targets the T cells and other white blood cells, also known as lymphocytes. These are the cells which your body has to fight infections and disease. The lymphocytes have surface receptor proteins called CD4 receptors, and it is this that the virus binds to enter the cell. The HIV virus essentially begins to destroy the cell from the inside out, integrating itself with the cell's DNA to create its own viral DNA, and thus create new viruses in a cyclical nature throughout its lifetime. The HIV virus binds to a specific CD4 receptor site on the surface of the lymphocyte, and then fuses with the membrane to release its viral RNA into the cell. A retroviral enzyme called reverse transcriptase, which is released along with the RNA, then changes the viral single-stranded RNA to viral double-stranded DNA so it can enter the nucleus of the cell. Another enzyme called integrase allows the entry of the viral DNA into the nucleus and integrates it with the lymphocyte's DNA. It is here that the viral DNA may hide and stay inactive for several years. The virus uses the cell's mechanisms to create more of its own DNA to synthesize proteins in order to produce more HIV viruses. Protease, a hydrolytic enzyme, then cuts up the proteins into smaller fragments which then combine with the HIV RNA to make a new virus. The new virus then pushes its way out of the lymphocyte cell membrane, destroying it. Budding allows the virus to be coated in some of the cell membrane containing the receptor sites, so that the virus can go on to bind to and infect new lymphocytes. Many responses correctly identified AIDS as the final stage of HIV infection, but there was still some confusion of what AIDS stood for. AIDS stands for Acquired Immunodeficiency Syndrome and is the later stages of the HIV infection in which the body's immune system has become severely damaged. Therefore, HIV and AIDS are linked, as AIDS is the medical condition caused by the HIV viral infection. Yes, if you do have HIV or AIDS, you are more susceptible to other diseases. The HIV virus attacks the lymphocytes in the body, reducing the ability of the immune system to protect itself, and therefore resulting in the progression to AIDS. An AIDS sufferer has a severely damaged immune system and are therefore more prone to opportunistic diseases such as tuberculosis, pneumonia, and cancer. A sufferer can die from having a common cold that would have otherwise been combated against in a capable immune system. The most common answer for the contraction of HIV was sexual transmission, so this is the exchange of bodily fluids during unprotected sex. Another common answer for the contraction was through blood transmission, so this is the sharing of hypodermic needles or invasive equipment. Few mentioned the passing of the virus from mother to child during pregnancy, childbirth, or breastfeeding, and this is called perinatal transmission. HIV can also be contracted by occupational exposure. Many healthcare workers are often in contact with infected blood or other fluids and can sometimes be infected if the virus enters their body. Rarely, contraction can occur through blood transfusions and organ donations. However, screening is a method used to detect the virus and thus prevents the spread. According to the NHS, at the end of 2012 there was an estimated 98,400 people living in the UK with HIV. That's around 1 in every 650 people. The beginning of the epidemic began on June 5, 1981 in Los Angeles, when it was reported that 5 young, previously healthy gay men had contracted a rare lung infection and also had a number of other infections. By the end of the year, there were 270 reported cases of immune deficiency amongst homosexuals, 121 of whom had died. However, it was soon discovered that the infection was not only isolated to gays, as women and children also began to contract the disease, and so the term AIDS was coined. The following statistics for the UK for HIV-positive individuals are as follows. Sexual orientation does not increase the likelihood of infection, as anyone is susceptible to the disease. However, homosexuals and African men and women are the most likely to contract the disease. All of the responses highlighted the signs and symptoms of HIV, mostly commenting on the flu-like nature of the symptoms. The initial infection of HIV is said to be the worst flu ever, as this is when the body is trying to fight the infection. This occurs within a month of contraction and includes fever, headache, tiredness, swollen glands, rash, fatigue, and these are all very common flu-like symptoms. The second stage is known as clinical latency. During this time, which lasts 10 years on average, the virus continues to be active, producing viruses and destroying the immune system, but only at a very low level within the tissues indicated. The term latency means a period where a virus is living or developing in a person asymptomatically, which means without producing symptoms, and so the individual may have no or very mild symptoms during this time. The progression of the viral infection into AIDS yields much more severe symptoms in the later stages, when the virus has severely weakened the immune system, and there is fewer than 200 CD4 lymphocytes per cubic millimeter of the blood. Symptoms include rapid weight loss, fever, fatigue, prolonged sweating, diarrhea, sores of the mouth, anus or genitals, reddish-purple blotches under the skin, inside the mouth, nose or eyelids, a loss of memory, and blurred vision. The development of opportunistic diseases such as meningitis, Kaposi sarcoma, and wasting syndrome tend to develop as AIDS grows increasingly more persistent in the body. It can take up to 3 months before HIV is detected in the immune system, but the following tests are available in hopes to catch the virus early on. The ELISA test determines for the presence of HIV antigens in the blood serum, while PCR testing is used to detect the genetic material of the virus in the blood of babies born to HIV-positive mothers, in order to determine whether or not the virus has been passed on via perinatal transmission. In 2012, nanotechnology detection of the P24 biomarker in the blood serum was developed. If P24 is present and thus yielding a HIV-positive result, the biomarker causes the gold nanoparticles to clump together and cause a color change from clear to blue. A negative result separates the nanoparticles, generating a color change from clear to red. Preventing HIV is definitely achievable and can be done by using condoms during sexual activity, having regular checkups at sexual health clinics, and avoiding sharing needles or invasive equipment. There are 2 types of preventative pill available: pre-exposure prophylaxis, which is taken daily, and post-exposure prophylaxis, which is taken within 3 days of the incidental exposure. Neither of these pills can fully prevent the infection, but they can significantly reduce the risk. Research is currently ongoing for further preventative measures, including topical microbicides, which are gels or creams that are applied to the vaginal or anal regions prior to sexual intercourse with someone who is HIV positive. And also vaccines, which allow your body to produce the antibodies against the virus before it has come into contact with it. There are 4 types of antiretroviral drugs which can control HIV infection and reduce the rate at which it advances, resulting in longer life expectancies for sufferers and enabling them to live a more normal life. The drugs can be combined and create an inhibitory effect on the different aspects of the HIV virus life cycle. Fusion inhibitors prevent the binding, fusion, and entry of the HIV virus into the cell by blocking the surface receptors it binds to. Nucleotide reverse transcriptase inhibitors can either competitively or non-competitively prevent reverse transcription occurring. Therefore, the formation of double-stranded DNA from the viral single-stranded RNA is not produced. Integrase inhibitors inhibit viral integrase and prevents the integration of viral DNA with lymphocyte DNA. Protease inhibitors prevent the production of virions budding from the cell membrane and thus prevent the spread of infection. Like all good scientific discoveries, this discovery was made by accident. The first baby from Mississippi, USA was given high doses of 3 antiretroviral drugs, and over 3 years later there is no trace of the infection in her blood, despite being off the medication for 2 years. The second baby from California, whose mother had not been taking antiretroviral drugs throughout her pregnancy, received the same high doses of the 3 drugs 4 hours after birth. 11 days later, the virus was undetectable and remained so 8 months later.